In this problem we have an oil tanker that spilled oil in a circular pattern, and the radius of the circle is increasing at the rate of 50 feet per minute. So this means that dr dt equals 50 feet per minute. What we want to know is how fast are both the circumference and area of the spill increasing when the radius of the spill is 20 feet and 50 feet respectively. Well, the circumference of a circle is 2 pi r, which means that dc dt, the rate of change of the circumference, when we take the derivative, would be 2 pi times dr dt. We also know that the area of a circle is pi r squared, and this means that dA dt, when we take the derivative with respect to t, would be 2 pi r times dr dt. We now have all of our necessary information. In part A, the condition is that r equals 20. That's the radius. So, dc dt is equal to 2 pi times whatever dr dt is, and in this case it's 50. So, the circumference is changing by 100 pi feet per minute. dA dt is equal to 2 pi times r, which is 20, times dr dt, which is 50. And when you multiply this out, we find that the area is changing by 2,000 pi square feet per minute. In part B, which we'll do in blue, the change is that the radius begins at 50 feet. Well, this means that dc dt, the change of the circumference, must be 2 pi times dr dt, which in this case is still 50. So the circumference is still changing at the same rate, 100 pi feet per minute, because the size of the circle has no impact on how fast the circumference is changing. But dA dt will be different, because the rate of change of the area is relative to the radius. In this case, it would be 2 pi times the radius, which is 50, times dr dt, the rate of change of the radius, which is also 50. And so when the radius is 50, the rate of change of the area is 5,000 square feet per minute.